Hello ladies and gentlemen, welcome to Edu-ca-te. Today we're going to be talking about the kinetic theory of matter, or the kinetic molecular theory. Okay, so this starts at the states of matter. Number one thing, the states of matter. So as we know that matter exists in three states, let's actually just rewind on them. So all matter has mass and takes up space. So to be able to prove something is matter, so matter is just basically anything that is tangible or anything that contains mass and space. So this is how you'll be able to define matter as anything that can be that is actually tangible, or by tangible just means that that can be touched. So it contains a mass, it means it has got heaviness in it, so it means it's got a mass. And then matter occurs in one of three states, which is the solid, liquid, or gaseous state. So we're actually having three states of matter which depend on the temperature. So remember, when you're having ice cold water, what actually makes water to be ice, it is because you put it in a refrigerator. So a refrigerator, what in the refrigerator makes the water to be ice? It is because there is actually a lower temperature. So the states of matter actually depend on the temperature, So if you actually take out an ice block from a refrigerator and put it near a hot surface, or maybe on a stove, it actually going to melt. Is because the temperature has changed, therefore it changes its state of matter to liquid. So it depends on the temperature. So the state of matter depends on its melting points and boiling points. So we actually have these new terms called the melting and boiling points. So the melting point actually is the point at which the matter changes to a liquid state. So this is called the melting point. So the melting, we usually use this term when we are referring to ice, which is melting because there's a presence of heat. So this is actually called the melting point. So the melting point just tells you about the temperature at which matter changes from solid to liquid. So we have got also the boiling point. So the boiling point of a substance, let's just abbreviate it with BP. So the boiling point of a substance is just this point at which this temperature at which its state of matter is actually going to change to the gaseous state. So this is the boiling point. So this boiling point tells us exactly when will an object or a substance melt, or when will it boil. So if the temperature is above the melting point but is below the boiling point, it is actually a liquid. So this tells us that if the temperature is below the melting point, meaning that it has not yet melted, but it is actually below also the boiling point. So it is actually a liquid. So it is above the melting point and below the boiling point. So by above the melting point, it means that it has melted. So if you take ice and melt it, it becomes liquid. Therefore, if it is below the boiling point, it is just liquid water which hasn't yet boiled. Therefore, it is considered a liquid. So if the temperature is above the boiling point, it is actually a gas. So once it boils, it means that it changes to the gaseous state. So it means once the boiling point is reached, it means the substance is going to actually convert to be in a gaseous state. So let's actually look at the changes in the state of matter. So here we're having the solid state, we're having the liquid state, and lastly we're having the gaseous state, the gas state. So here, let's actually look at the processes that happens. So here, from solid to liquid, there is a certain process that takes place which is called melting. So melting is actually the converting of a substance from a solid state to a liquid state. So let's actually look at the reverse of it. How can a liquid turn to a solid? So the reverse of it will be freezing. So freezing is actually the opposite of melting, because when something is melting, it is actually moving from solid to liquid, and when it's freezing, it's from liquid to solid. So from liquid to gas, let's actually look from liquid to gas. So from liquid to gas, there is also another process that is called boiling. So boiling is when a liquid changes into a gas, basically. So this is also called evaporation, because a gas evaporates. So it's boiling or evaporation. And then we have got condensation that happens in reverse. So this is called condensation, whereby a gas changes to a liquid. So we can actually see that we have covered the solid to liquid, liquid to solid, and then liquid to gas, gas to liquid. But then actually, let's actually look what would happen if a solid changes directly into a gas without going through the liquid phase. So there's actually a process for that. So from solid, right from solid to the gaseous state here, there is a process called desublimation or deposition. So this process, it is a process, actually, let me actually change the arrow of this. So yes, this process is whereby a gas directly changes from gas, where substance directly changes from gaseous state to solid, but without passing through the liquid phase. It is called deposition, or otherwise called desublimation. So this is the process whereby a gas directly changes to a solid without passing through the liquid phase. So let's actually look what happens in reverse when a solid changes to a gas without passing the liquid phase. So here, from a solid all the way to a gas, there is actually a process called sublimation. So the prefix of the converting, which we saw here from gas to solid, is actually D. It means it is actually opposite to what? To sublimation. So sublimation takes place when a solid changes directly from, so when a substance changes directly from a solid to a gas without passing through the liquid phase. So this is the state of matter. Okay, so let's look at the heating and the cooling curves for water. So here we are having water. So let's actually draw a graph. This is our x-axis, this is our y-axis. So water moves from here. Let's actually put the temperature here in degrees Celsius, and then let's actually put the time in minutes. Okay, so let's look at the melting and boiling points of water. So here, when water here starts, this is the increase in time. You can see that the time is actually increasing as this line increases, right? So first, in this case, it is in a solid state. This is where it all starts, in a solid state. So when it's in a solid state, at a certain point, it is to what? It is to melt. So melting will take place here. Remember, we said that melting is a process whereby a solid changes into a liquid. So after melting, after a certain time, it will also what? It will also boil. So this will be called what? Boiling. So at this point, this temperature here actually is called the boiling point, and then this temperature here is called the melting point. So this is the heating cave of water. So this is called what? A heating cave. Why do we have to call this a heating cave? It is because actually there is heat applied. So for a solid to melt, take it for an example, for ice to melt it to apply heat. So this is a heating cave because it is actually explaining how water changes from solid up to the gaseous state through heat. So let's look at this called a cooling cave. So a cooling cave So a cooling cave starts all the way there and condenses here. So here there's condensation taking place. Okay, so remember that a heating cave starts from a solid. It cannot start from a gas, because if you apply heat to a gas, nothing actually happens to it. So it has to start to a solid. So in this case, there is what? It starts here at the gaseous state actually. So this starts at the gaseous state or the gas state. So for it to change to the liquid, it is to condense. This is the process called condensation. So we actually looked at that. So, and then later on it freezes. This is the freezing process. So first of all, it was in a gaseous state. It changed, it condensed to a liquid state. So if we're going to check here, this is the liquid state, and then back to a solid state. So this is actually the heating and cooling cave. So this is actually called the cooling cave. The cooling cave of water. So we have seen the cooling cave and the heating cave. So let's actually dwell in the kinetic molecular theory of matter that says all matter is made of tiny particles with spaces between them. So this tells us that there are certain particles with which are making what? Which are making matter. Okay, so particles are just the small things which are building up something. So we can actually consider them more like atoms, or more like bricks which are building up a house. So it continues to say that the tiny particles are constantly moving, meaning that they are not still. They are moving constantly, but the particles lose no kinetic energy when they collide with each other or with the walls of their container. Okay, let's actually look at the particle diagrams here. So we have got what? We've got a solid. So a solid actually has got particles which are actually closer to each other. So it means that they are built closer to each other. So this is building up a solid. Any solid substance you might know is actually built up of particles which are actually closer to each other. So they've got a fixed volume, or they cannot easily move. So here they've got what? A fixed volume. By a fixed volume, it means that it can never be altered into another volume. Okay, so they've got also a fixed shape. If we take an ice also, it's in a solid state. Ice, just an ice block, it is in a fixed shape until there's heat which changes it to a liquid. And then the spaces between the particles are just touching with each other. So this just tells us that here you can see that these particles are closely bonded to each other, and then the forces between the particles are actually strong forces here. There are actually strong forces between the particles, and then the arrangement of particles are actually close together, fixed positions in a set of pattern. And then the particles actually vibrate about fixed positions. It means they do not just move, they just vibrate. They do not actually move and lose kinetic energy. So let's look at the liquid state. So a liquid, let's actually look at the particle arrangement. So here we're having one particle, maybe connected to each other, another one, something more like this. So this is just depicting or describing what a liquid particle, how are the liquid particles bonded with each other. So they've got a definite volume. And then they take the shape of a container. Remember that in the solid say they've got a fixed shape, but then these ones take the shape of the container. Take the shape of container. So if you actually put water in a cup, the water will actually take the shape of the cup. It will never be something else, except it is maybe in solid state, which means it's an ice block which is fixed shape. So an ice block will always be in the same shape. But then if it is just liquid water and you pour it in a cup, it will actually take the shape of that container, which is the cup. So these particles are actually touching each other a bit, but then they've got medium forces between the particles. Remember that the solid forces are strong. That is why it is quite hard to actually break a brick rather than just pour water or something like that. So they've got medium forces between them. It's not actually that strong because the particles are kind of far apart from each other. They're not actually bonded strongly so. And then they've just got a random and no fixed pattern. So there is no fixed pattern. So by no fixed pattern here, it means that it can take the shape of the container. It is actually the one and the same thing. So it means the pattern of the particles can be changed because they are in a certain container, which is of a certain shape. So there's no actual fixed pattern of the particles in a liquid state. And then they slide past each other, switching places. So they slide past each other. So remember, the solids just vibrate, but then the liquids will slide past each other and just taking different positions. It means that water cannot be just in one place, or one water particle cannot be just in one place. It is not fixed. So this is it. Let's go to the gaseous state. So the gas state, let me actually draw the particles. So these are depicting the gaseous state. So they've got no definite shape or volume. So there is no definite shape or volume. Okay, reason being, you can see that a gas can just occupy any space in the air, right? So take it for example, you can take smoke from a boiling pot. It is actually just dispersing in the air. So it has got no definite shape, it has got no fixed pattern and stuff like that. So the particles actually expands to fill container or space in which it is in. So if we actually take smoke and put it inside some container, it is not actually going to take any shape. It's just going to expand. The particles are just going to expand and fill each and every space in them. So the spaces are actually far apart. The spaces between the particles are actually far apart, and then the forces between the particles are very weak, meaning that we can actually alter a gas. By that I just mean that you can actually take it for a smoke which is coming from a boiling pot. You can actually wipe it away, and then later on there's no longer a gas which you can see. So this means that they've got weak forces between the particles of the gaseous state. And then the arrangement of these, they're just on their own. The particles are on their own. So remember that in the liquid, they're actually a bit closer to each other and they slide past each other, but then in the gases, they're on their own. So it means one particle can go the other way, another one another way. So the movement of particles is fast and free. Fast and free. So by fast, it just means it moves fast in the air, and you can see smoke moving fast in the air. And then free, it means just it is the particles can go they're on their own. It means they can go in different places. So this just tells us about the states of matter. So the kinetic molecular theory is actually based on this. So the molecules or the particles are actually describing these forces between the forces between the particles of a certain state of matter. Therefore, when you're going to mention the kinetic molecular theory, you have to mention first the melting point, and then the boiling point. So this is usually when you are given what we call a heating cave. So this is usually when you're given a heating cave. Usually when you're given a cooling cave, you have to mention first of all the this point at which the gas condenses. So this is the condensation, and then later on you have to mention the freezing point, or the point at which this substance will actually turn into a solid state. So this is what the kinetic molecular theory is based on. Thank you for watching. Please don't forget to subscribe.